In this video, we take a look at the concept of radioactive decay. The basic building blocks of the nucleus are proton and neutron. In a neutral atom, the nucleus is surrounded by one electron for every proton in the nucleus. The number of protons in a nucleus is referred to as the atomic number Z. So typically, for a neutral atom, Z is also the number of electrons that surround the nucleus. But atomic number typically refers to the number of protons in a nucleus. Whereas the number of neutrons is referred to as the neutron number N. So you have atomic number Z, number of protons, neutron number N, number of neutrons. The nucleon number or mass number A is the sum of the number of protons and number of neutrons. So A is equal to Z plus N. The mass number is equal to atomic number plus neutron number. The mass number is basically the nearest whole number to the mass of the nucleus measured in atomic mass units U. 1 U is equivalent to 1.6605 times 10 to the negative 27 kilograms. And when converted to energy, 1 U, 1 atomic mass unit, 1 U is equivalent to 931.5 mega electron volts. A specific combination of protons and neutrons, so a specific combination of Z and N is called a nuclide and is a unique nucleus. The following notation used to represent a particular nuclide is, you have the following notation. You have element X, A, Z, and N. Atomic number Z, neutron number N. So atomic number Z, neutron number N, and then nucleon number, mass number A. So A, Z, and N. Isotopes, on the other hand, are nuclides that have the same atomic number Z but different neutron number N. So same Z but different N. About 2,500 nuclides are known, but only fewer than 300 are stable. The rest are referred to as unstable structures. Unstable structures decay to form other nuclides by emitting particles and electromagnetic radiation. This process is referred to as radioactivity. The time scale for these decay processes to happen ranges from a small fraction of a microsecond to billions of years. It all depends on the nuclide that is decaying. When unstable nuclides decay into different nuclides, they typically emit alpha particles or beta particles. When alpha particles are emitted, you have alpha decay, while if beta particles are emitted, you have beta decay. So first, let's have alpha decay. Alpha decay or alpha emission occurs principally with nuclei that are too large to be stable. When a nucleus emits an alpha particles, its n and z values each decrease by 2, while a decreases by 4, which makes sense because a is equal to z plus n. So if n decreases by 2, z decreases by 2, that means a will decrease in total by 4. An alpha particle is basically a helium nucleus, that is to say, two protons and two neutrons bound together. Mass of an alpha particle is around 4.002603 U with a total spin of 0. So in essence, alpha particle is a helium nucleus, no electrons. On the other hand, beta decay, we have three different types of decay. You have beta minus, beta plus, and electron capture. Beta minus decay usually occurs with nuclides for which the neutron to proton ratio n divided by z is too large for stability. N is very much larger than z. A beta minus particle, beta minus, is basically an electron. The emission that is emitted by the nucleus. So, an electron emitted by the nucleus, you have a beta minus particle. Emission of a beta minus particle involves transformation of a neutron into a proton and an electron. So emission of an electron by a nucleus, but a nucleus is comprised only of protons and neutrons. There are no electrons in the nucleus. So somehow the nucleus emits an electron, and this happens by transforming a neutron into a proton and an electron, as well as what is referred to as an antineutrino. An antineutrino is an antiparticle of a neutrino. Both neutrino and antineutrino have zero charge and zero mass, and therefore produce very little observable effect when passing through matter. On the other hand, beta plus decay usually occurs for nuclides wherein n over z is too small for stability. N is very much smaller than z. So beta minus, nz is too large. Beta plus, nz is too small. A beta plus particle is basically a positron that is emitted by the nucleus. A positron is the electron's antiparticle. It is identical to the electron, but instead of being negatively charged, it is positively charged. So it's a positively charged electron, so to speak. Emission of a beta plus particle involves transformation of a proton into a neutron, a positron, and an electron neutrino. So proton brings about or is transformed into a neutron, positron, and a electron neutrino. So this should be beta plus, not beta minus. Okay, so correction here, this should be beta plus. Lastly, we have the electron capture. Electron capture can occur with nuclides for which the beta plus emission is not energetically possible. but in which an orbital electron can combine with the proton in the nucleus to form a neutron and a neutrino. The neutron remains in the nucleus and the neutrino is emitted. So you have a proton combining a with a beta minus with an electron to produce a neutron and a neutrino. The neutrino is emitted by the nucleus while the neutron remains in the nucleus. You have electron capture. We also have what is called gamma decay. When a nucleus is placed in an excited state, either by bombardment with high energy particles or by radioactive transformation, this excited nucleus can decay to ground state by emission of one or more photons called gamma rays. Gamma rays have energies that typically range from 10 kilo electron volts to 5 mega electron volt. This process is referred to as gamma decay. And that's it for now. In the next video, we'll take a look at the concept of the half-life. So thank you for watching.